In these videos, we're going to look at how we use the binomial expansion when you have a negative or a fractional power, which we get or obtain an infinite series. So what we have to know is that we want all of our brackets to look like this: 1 plus x, or it could be 1 plus x over 2 or 1 plus x over 5. It doesn't matter. As long as we've got it in that form, then we're in the right stage. So raised to the power of n, and we have this version of a binomial expansion also, which belongs to this series or an infinite series. So we say that we have 1 plus n times x plus n times n minus 1 over 2 factorial plus n times n minus 1 times n minus 2 over 3 factorial times x cubed plus other terms. Because it's a series, the series continues. So if we take this example here, we have 1 over 1 plus x. Now that's the same thing as 1 plus x, all raised to the power of minus 1. So in our case, we have a negative power, as in minus 1. So our series expansion would be 1 plus n is minus 1 times x plus minus 1 times minus 2 over 2 factorial. This should be an x squared here. So we need an x squared there. We want the first 4 terms, so we're going to do plus minus 1 minus 2 minus 3 over 3 factorial x cubed plus other terms. Now that means that our series, we end up with the following: 1 minus x, then we get plus x squared, and then we get, well, minus 1 times minus 2 is positive 2 times minus 3 is going to be minus 6. But then don't forget, 3 factorial means 3 times 2 times 1, and then we've got an x cubed. So we can cancel these terms out like so. And then we end up with the following. We get 1 minus x plus x squared minus x cubed, which is our series, plus other terms. We can't forget that. In our next example, we have brackets 1 minus x all raised to the power of a third. So what we're going to do is we're going to write this out here. So it's 1 minus x raised to the power of a third. Now notice, in our case, n will be a third, but we need to be careful. In the formula where we've got x, we need to replace that with minus x. So we're going to write it as 1 plus n, which is a third. Now be very careful here, you can't write x, you have to write minus x. Okay, plus a third. Now a third minus 1 is minus 2/3 divided by 2 factorial, and then we've got minus x all squared, and we're going to go up to the x cubed term. So we're going to add another line here and say that's going to be a third times minus 2/3, and then don't forget we need to do n minus 2, which is going to be minus 5/3 times minus x all raised to the power of 3 plus other subsequent terms. Now, simplifying that, we can simplify these coefficients on a calculator quite easily. And don't forget, we need to divide this by 3 factorial. So I'm going to put that in here, 3 factorial. And then we can now simplify all the coefficients on a calculator. And what we end up with is the following. We're going to get 1 minus 1 over 3 x minus 1 over 9 x squared minus 5 over 81 x cubed plus other subsequent terms. Now, a lot of the time in exam questions they'll say state the range of values of x for which the expansion is valid. So we'll take a modulus. Now we don't have x, we're dealing with minus x. And we generally say that this is less than 1. Now the mod gets rid of the minus, so we can say mod x is less than 1. But to write this in full form, we say x is greater than minus 1, but strictly less than 1. So in the next example, we need to find the first 4 terms in the binomial expansion, or the binomial series, if you like, of 1 plus 4x raised to the power of minus 2. So let's write that down. So we've got 1 plus 4x raised to the power of minus 2. So in our case, it's 1 plus, now n is going to be minus 2 times by, instead of x, we've got 4x. And then we've got minus 2, then minus 3 times 4x all squared divided by 2 factorial. I'm just going to write the third term over here a bit further down. So then that's followed by minus 2, minus 3, minus 4 over 3 factorial times 4x all cubed plus other subsequent terms. Then we can simplify all of that on a calculator, and we're going to end up with the following. So we end up with 1 minus 8x plus 48 x squared minus 256 x cubed plus other subsequent terms. Now, if they stated state the range of the values of x for which the expansion is valid, then what we would do, instead of x, we're now going to take 4x, or mod 4x if you like so. I'm just going to put a bracket around it so we know it's mod 4x. So it's mod 4x, and we divide it by 4, so we say mod x is less than a quarter. But when you remove the modulus sign, you're going to have plus or a minus. So we say, therefore, the range required is x is greater than minus a quarter, but less than positive a quarter. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we have 1 plus 3x raised to the power minus 3. So in this question, we're going to use the formula. So we're going to say 1 plus n, which is minus 3. Now careful, x in our case would be 3x. So you write 3x here, plus minus 3 minus 4 over 2 factorial times 3x squared. And one more term, minus 3 minus 4 minus 5. To improve the clarity of that. divided by 3 factorial times 3x all cubed plus other terms. So using our calculator, we will get the following results. We will end up with 1 minus 9x, like so, plus 54x squared improve the clarity of that, minus 270x cubed plus other terms.